Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, welcome again into this TV Listen Learning program. I'm teacher Jean-Marie. Remember the last time we have discussed about physics of senior 4, and I said that the senior 5, senior 6, they have also to enjoy with this practical activity. Just it is a practical that they did into the previous levels. Okay? So the title of that experiment was the determination of focal length of the lens. You remember that? This was the title of that experiment. And we have determined the data from that experiment. Now today, we are going now to analyze the data until we find that focal length. But I remember, I asked you to think about this average focal length. This is the method that we are going now to use. Let's calculate the focal length by the mean value of the focal length that we have determined the last time. So we have determined the 5 focal length. And what we have here is the F1, and this is F2, F3, F4, F5. It means that to find F average, we have just to sum these two, we add F2, F3, F4 plus F5 over 5. And then we substitute the value that we have, that is 19.2 plus 19.4 plus 19.5 plus 19.7 plus 19.6. And then this is divided by 5. So this is the average focal length. And that average focal length will now be equal to, let's use the calculator and we find. So we add these ones. So we have the values, and then we have it is equal to 97.24, yes, and then we calculate, then we over 5, this will give, remember the answer here has now to be into centimeters, and then we have this is over 5, we find 19.48 centimeters, but because we have used now 1 decimal place, it means that we have a 19.25 centimeter. This is the focal length that we calculate by using this method, average value. Now, let's continue now to analyze more about this data, but by using just the graph. Number one, let's have from the procedure that I gave you the last time that we have used it. We have used a procedure into which we have U, then V. This is just expressed into centimeter square because it is a product. and this is U plus V, and then here it will be centimeter. So then after, we take this times this one, and we find, okay? Yes, good. We're going now to find the value will be now equal to 1484.0. So our decimal place that we are going now to use is 1 here, there. So and then next, what do you have here? So when we add the two, we have a 77.24. And then another one. And another one is going out to be well calculated. So we have this data, that is 40, then times the 37.5, then equals to 1500.0, and then the sum is 77.25. And then next we have to take this 45 times that one equals to, that is 1543.5, and the sum will be equal to, 79.5. And another data that we have determined the last time that I have copied there, you can now use this. And then we are having, this is this is 50 times 32. Then this is equals to 1,060 1,620. Then we have one decimal place, and the sum of the two gives 82.4. 82.4. So we go next to another one, and that was Z55 times Z30, and then we find 1,677.5. Okay, then the sum will be equal to 85.5. So I think we are done with the data according to what we have from the table. From the table, it was a step number, another step that we have. First of all, what we did by the last time, we pressed the metal ruler on the table and fixed the light source assembly. And then after we placed the lens in its holder at a fixed distance, and then we moved the screen towards or away from the lens until a sharp, clear image is formed. We measured the image distance V between the lens and the screen. This is what we did. You remember that? And another that we did is now to substitute the value into the formula to find this. And then we repeated the experiment just several times. We find just this 5 times. And then we are going now to construct a table. This is the table that we have into where we have all of this UVF and UV, and then U plus V. So we are going now to plot a diagram. So a diagram that we are going now to plot, we use this paper, and then we transfer the data on this paper. So number one, we have the points. So we need now to have here let's say that this is going out to be the axis. So we draw here the axis, the analysis of the data. This is the axis. So, and let's say that there is another axis. Have the two. This is an axis. Okay. Then we have from these two axes. So we have this is the arrow here. And let's say that we are going now to, this is another arrow. And then because we are now plotting a graph, this is a graph of this is UV against what we have there as U plus V. So this is what we have, and so it means that we look at this and we have it at this axis, the vertical axis, and the other one is only the horizontal axis. So the value that we have, let's now use just a good method that is going now to help us now to put the data on our graph. Number one, let's have let's leave this value. So let's say that here we leave we change this value in this way. We say that, what if like that 14.84, and then we say times 10 power 2, and then this is going out to be centimeter square. Do you see this value? And that is 1. And then another value, we say this is 15.00, and then times 10 power 2 centimeter squared, and so on. This will now be simple because I will now be simplifying the data to be here, just to be arranged maybe up to 10, then times Z. Here I have this is going out to be U, then V, then this is Z over, it is Z, unit is Z centimeter square, and the values there, they are going out to be in times 10 power 2. It means that now I will be using this 14, 15, and then here I have 15.43, 16, then here 16.77. Now, so as what I see, let's say that I have this is the graduation. So I have here a graduation. Let's say that I have this is going out to be 2. I graduate it like this, and then this is 4. I have it here as 6. I have it there as 8. And then let's say that this is 10, and then here it is 12, and this is 14. Here is 16, and then this is 18. So 18 that I have, then I will now I will know where 16 is, 14 where it is here already. So then after I also have this graduation on this, whereby we can now say that we are, this is 20, and this is 40. Okay, so here we have 20, this is 40, this is going out to be 60, and here let's say that is 80, and here we have 100 and 120. Do you see that? Here we have the values, and you see it is graduated like that, and here we have U plus V then in centimeters. Listen, the axis that we are having here is U plus V in E. This is in centimeter. Okay, students? Now, let's have this point data into what we are having. So number one, we have 14, and then 77. Now, according to what we have here, this is 80. It means that here this is 60, and then 80. No, 70. And then we have a 77 up to this 14. That is the, let's say, that is the 14.0. Yes, 0.8. So we have it there. And this means that we have 14.0. Because it is now 14. Let's see. At this 14, at this 14, I have 8, and this 8 is in here. So this is the 8, and then 14, okay, 8, and then after, I have to find this, I have to extend it up to that. And then for 70, it is here. Then it is in the half. Then 77.4. 77.4. Then I have that. This is okay. Then it is going out to be here. Okay. So I have that this is the first point, and a point that we have is this one. Okay. This is the point. I have that it is readable to you. Okay? Do you see that? Good. And let's see another point 2. Point 2, we have a 15. So 15, as what we have here, it is the half of that. This is the 15. And then we have, and this is going out to be, we extend the line. Okay, maybe we are going out to solve by here, and then we find this 77 again. It is going out to be somewhere here. And then we have another one. Okay, another one is going out to be 15. And this is 0.4. 15.4, are you following how I'm drawing that? Yes? Good. Then I have, this is okay, so this one, 15, and then I draw, this is 15.0, 43. So this is the 1, 2, 3, 4, 4 here. Then that is the 43. And we do this. We join up to this point. And remember, what we have there is the 79. And we have it up here, and we, okay. Now, so this is another point, and we go next to another. So here it is 16. You see now we extend our points up to the 16.2. 16. Hope that you are now still following. Yes. 16.2. Okay, so this is the 16 here, then 1, 2, that is 2, and then we shall draw this to find the intersection that is on the axis that we are going to draw after. As we see there, 82.4, it means that this is from this axis, this is 80, and then we have now to find this point, and the point is this one. Okay, now we find here another point. Wow, this is a point 4. And another point that we can now just finish to, it is this is 16. That is 16.77. Okay. Then let's have now, this is 16.77. Remember, the value that we are using is what we have changed. By using this 10 power 2, and that is this 16, and then 17 here. Okay, so 16, let's see, 16. Up to there, we go up, and we find up to here it is 17, then this is 8. And then 77. Then we will also draw this line to find where it is going now to intersect with the one that is coming from the axis whereby we have the 85. 85.5, there we have 80. Let's see, this is 80, then this is going now to be 90, 85 in the half, and we draw this line joining the two. Okay, then after we find this one. So did you follow how now I have determined this intersection of the points, the data? So 1, 2, 3, 4, 5 points. So now I have to draw a line that we call the best line of fit. What is this line? I hope you remember the line. Huh? So the best line of fit. This is the line that we define now to be just to be having to draw, just to pass it through approximately all of these points that you have determined there on that graph. Do you get that? Then let's draw that line. Let me use another different marker. So because that is going to be a line. So if I draw, let's see, the best line of it, let's say that is going to be this one. Do you see that? Very good. Okay, now I have to draw into the next step. They are telling us now to draw what we have as the slope. Do you understand the slope? The slope, let's draw it. I hope you are still following now. Slope. And then we have, this is the slope that I have here. So which means that, let's say that this is a change of u plus v, and this time will be equal to, that is here we have, down there we have, this is going out to be here it is going out to be 90 minus minus what? You are not, okay, fine. So this is going out to be minus 73.2, and then here let's find that is 70. Let's find that is equal to 16.80 centimeter. And then here we have, this is the change of V and this one. I hope you see this. Yes, student? Good. Do you see this? Fine. Then here it is going out to be 17.8 minus 14, because this is 14, and then here we end up having now, just we subtract. And then what do we find here? That is, it is simple. Then there we have, what do we have? We have 17.80 minus 14. Now to be correct with this, we have to use a calculator. This is a 3.8 centimeter only. Yeah, you get that one, it is centimeter square, because it was a product. Good. Now, let's find the slope. The slope here, I hope this is good for you. So just write. Is it okay? Can I? Okay. Now, so what do we find here? To find the slope, that is slope S, this will be equal to the change in what we have as the odd there over the change for what we have as the abscess. And then this is going now to be, here we have a 3.8 centimeter square over 16.80 centimeter. And then this gives, what do we have as the S, the slope? So the slope here is going out to be, I hope that is 3.8 over 16.8, and this is equal to 0.22, just 61. Now remember, students, you didn't now remind what we are doing here. So down there and up here, there is something that you are forgetting. What? Here, we don't really have this only. We are having even a times z. There we have times, this is, it is equal to 3.80 times 10 power 2 centimeter square. So this is now, when you use this, you are now not correct. Do you understand? Then here we have times 10 power 2 centimeter, because we have closed out this 2 and the centimeter, and we remain with this. So this now is F, which is equal to 2.61, then centimeter, in other words, approximately equal to 22.6 centimeter. Now you can compare the two. They are closely to each other, but not really equal. Compare this value and the value that we came now to obtain by calculation and by analyzing the data. We have this table as the table of results. Okay? This is what we have now completing as the table of results. Okay? So I hope you have now to make sure a table of results is really designed as this one. Good, student. It was really good to have you into this practical activity. And I hope to meet you again into the next other lesson. Thank you, bye-bye.
Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.